Hello, everybody. My name is Angela Para, and today I will be presenting our research on the myoglobin determination of adult Florida manatees. I worked with Kinsley Philemon, who has since graduated, and under the guidance of my professor, Dr. Corey Newton. For the introduction, marine mammals have undergone several adaptations that allow them to extend their dive durations. Some adaptations that allow them to have increased oxygen storage are higher volume of oxygen in the lungs, also enhanced hemoglobin concentration in the blood, and having increased myoglobin levels in the muscle. For example, the oxygen-carrying molecule myoglobin will prolong aerobic respiration that increases ATP production during dives. The increase in ATP can extend muscle contractions, which can prolong dive duration for prey capture. The myoglobin concentration has been determined in many marine mammals, but there is limited information about the concentration found in Florida manatee swim mussels. We perform myoglobin determinations for both Florida manatees and minke whales. The minke whales to serve as comparison. As far as the methods go, this process was performed on both adult Florida manatee skeletal muscle and adult minke whale skeletal muscle. We took 1 gram of muscle tissue, which was then homogenized in phosphate buffer using a pestle and mortar and a motorized homogenizer. The homogenate was then centrifuged for 1.5 hours. We collected a supernatant, which was then bubbled with carbon monoxide for 8 minutes, then treated with 0.02 grams of sodium thiosulfate, and additionally bubbled for another 2 minutes with carbon monoxide. The supernatant was clarified via a short centrifugation, and supernatants were removed. Collected supernatants were then measured for absorbance at 536 nanometers and 568 nanometers using a spectrophotometer. Collected absorbance values were used to calculate myoglobin content using a previously derived mathematical equation. For figure 1 here, it is showing the myoglobin protein structure, which is the oxygen-carrying molecule I've been referring to in the skeletal muscle. Figure 2 shows the myoglobin levels in swim muscles of other marine mammals, and the concentration is in milligrams per gram of wet tissue. The manatees having 2.93, with the other 4, the lowest being 16 versus the highest being 40. Figure 3 shows the myoglobin concentration of minke and manatee. This is a summary of our results. The myoglobin concentration for adult minke was 20.6 milligram per gram, and the adult manatee was 2.93 milligram per gram. For our discussion, manatees have a lower concentration of myoglobin in their muscle than in minke whales and other marine mammals. This lower myoglobin levels in the manatee's muscle may be due to their choice of diet. Manatees are primarily herbivores, feeding on a variety of submerged and floating shoreline vegetation. A diet of this nature would require less energy expenditure when compared to other marine mammals, which feed on more mobile prey. The lower level of myoglobin concentration suggests the oxygen stores are depleted quickly during dives. Therefore, other key characteristics of skeletal muscle that contribute to dive capacity need to be explored, such as buffering capacity, muscle fiber type composition, and levels of high-energy phosphate compounds. We'd like to acknowledge the Florida FWC for providing the manatee muscle samples and the Natural Sciences Department for providing laboratory materials and equipment. And below are our references. Thank you so much.